Hello everyone, welcome back to our YouTube channel, and today we are going to solve a new question from our top interior 150 question series. And today's question title is minimum number of arrows to burst balloons. So this is a very interesting question which you have generally seen, and whenever there is an occasion you got to get in the fair and where you see a man having a wall full of the balloons and you have been given a gun to shoot that balloon. This is a similar situation where we have to shoot the balloons, but the difference is that instead of shooting in the from the front, we have to shoot from the downward direction. That means in the positive y direction. So in this situation, in the question, we have been given that the balloons are being pointed or been located in the xy plane, and there is given a input array which has the coordinates of these balloons, and these ranges are the diameter for each balloon. So in the example, you can see that 10 to 16 is the diameter for the one balloon. The next balloon has a diameter from 2 to 8. These are the location of x-axis. That means from x equals to 10 to x equal to 16. So that's how the balloon has been pointed. And what we have to do is that we have to shoot up with arrows in the vertically upward direction. That means in the positive y direction. And we have to finally find that what is the minimum number of arrows which will be required to burst all the balloons on the wall. So now let's try to find out the approach by which we can solve this question. So I have taken the example from our question. And this example, you can see that we have been given the diameter of the each balloon which has been positioned and xy plane. Now here I have also drawn the 1D diagram. In this you can also assume that these are the balloons having the diameter. Now what we have to find is that we have to find the points on which we can able to get the maximum number of balloons. So you can see that if you try to fire the arrow at this position or this position, you are able to get the two balloons at a time instead of one. So these are the points which we have to target. That means using one arrow, how much the maximum number of balloon which you can achieve. Now, how we can do that is that you have to just find out that how many of the balloons are going to be aligned in a line. So, if we have to find this, that means you have to find that if you try to burst the first balloon, along with this first balloon, how many balloons which you can break. So, this is the point. So, how we can do that is that we have to check that the next balloon after this first one is it lying in between the diameter of the first one or not. So how we will check if the end index of the current balloon diameter, if it lies between the start and end index of the second balloon diameter, then you can say that you can get the second balloon in the same arrow in which you are going to break the first balloon. So this is the point which we are going to follow. That means we are going to check it using the end position of the current index. Now, if you are going to check using the end index, and why we are using the end index only, because if you sort this array, because we need to sort this because these are given in a not sorted order. So in order to find the balloons in the sorted order, we have to first sort this. So after sorting, this will look like something like this. So this is the sorted order. Now there is a 2 point. That means first we can sort using the first index. That means the smallest first index comes first, which is sorted in this manner. This is the sorting in which the a smaller first index is at the first position, and the next one, then next one, then next one. But we have to make sure that the end index of the first one doesn't move beyond the second one end index, because what happened is very important to understand. So let's assume that this now extends to 10. So what will happen that if you check for the end index lying between these two positions, you are not able to get it, and you are going to lose the balloon. That means you have to increase your one number of count of arrows. So this will going to increase your arrows, and this is not going to give us a minimum number of arrows. So in order to solve this situation which is going to come into your hand, what we are going to do is that we are going to sort these points using the second index. That means this second index, that means the end index of the diameter, is going to be our key point by which we are going to sort it. So after sorting, you will get something like this. So this is the sorted points array in which we have this sorted order in which we have sorted using the second index. That means we have 6 one first, then 8 one, then 12, then 16. So we have considered this, but in this situation, both is going to be same, because we have the situation where the start and end index are in the same pattern. That means both are in sorted order. So this is the concept which you're going to follow. So after sorting this, we can simply check for the end index, and until we are not able to uh, get in situation where it doesn't lie between these two positions, we can simply escape it, and that means we can break these balloons in one arrow only. And when you get a situation where the end index lie beyond that next balloon, so we have to increase our count of arrows. So we will just shift our end position to the next one, and we will again check for the next ones. So now let's code this and understand how we can do. So let's start by sorting our points. Right, sort points dot begin, comma, points dot end. Now this will sort our points vector in order in which will be sorted using the first index. That means first index will be our criteria for sorting. Now in order to sort it in a order in which their second position, that means the second index will be our criteria to check. So what we are going to do is that we are going to create another function type bool, and let's take it as check, or you can say second. And what it is going to take, it is going to take two vectors, vector and address of a, and similarly it is going to take a vector b. So we have taken b. Now simply what we have to do is that simply we have to return a1 less than b1. So this is going to give us the sorting order. That means we have to simply call this function. So this will sort it according to our second index. Now next we have to take our second index. So we can take end as equals to points, our 0 comma I, which is 1. Next we have to also take a variable answer. First we are taking it as 1 because when we start from the first index we already need one arrow. Now we are going to run for loop and I equals to 1 because you already taken for the 0th. I less than points, size I plus plus. Now next what we need to do, we need to check the condition which we have discussed. That means if points I0 is less than or equals to our E, and points I1 is greater than equals to our E, that means it is going to be lie between the start and index of the next diameter. So we have to escape it. So we'll continue. In else part, what we have to do, we have to simply update our answer. That means answer plus plus, and we have to simply update our endpoint is equals to points I comma 1. Now this is going to give us the result. Now simply we have to return answer. Now let's run this code. So this is accepted. Now let's submit this. So this is accepted. So this is a question for today. This is an interesting question to understand. Now let's you are going to see the solution of the both Java and Python in the same video. So stay tuned and let's meet in the next video. Till then, keep learning, keep exploring. Thank you.